First of all, let me introduce myself. My name is Yuri. I'm working at Cyclone for almost 5 years on one project. Overall, I have around 20 years of IT experience and have background working for Barclays Investment Bank. Also, I participated in e-commerce project for quite big American company, Rodan & Fields. And overall field of my interest as of now, it's DevOps in general. So let me cover what the agenda for today's call. So first, we will talk about complexity of Git landscape. So the name of such presentation, it's a Git platform. And Git platform is nowadays more than just system control version. It's become more sophisticated and more complex. And we will cover a little bit this complexity, why Git platform, it's really like a platform and not a system control version. We will touch CI/CD productivity comparison if we are talking about on-premises and cloud resources. So CI/CD, it's an important part of modern Git platform, and we will talk a little bit comparison of CI/CD productivity. Also, important point will be cost of ownership, because different models, how to host and manage Git platform lead to different cost of ownership. And in the end, we will talk a little bit about challenges and summary. So I'm working on Toradex AG project, and let me shortly describe you the business of Toradex. Toradex, it's a Swiss company. It producing system on modules or system on chips. So it work in embedded field. It's slightly different from general IT as we can imagine it, but nevertheless, it's also producing like microelectronics and producing software. So on software, Toradex propose its own Linux so-called board support package. It means your microcomputer needs some kind of embedded level software. Usually it's called BSP, a BSP package. For example, for different variety of device, they use or general BSP or specific BSP. If we are talking about the specific project, then BSP usually rely on Linux kernel. And also Toradex propose a little bit higher level of software. It's called Horizon OS, Horizon Operation System. It's also free and open source industrial embedded Linux OS, but using Docker as a main runtime. And it's supposed to execute like Docker containers as an application. It's a little bit higher level of board support package, but nevertheless, that's the business of Toradex and project which I'm working on. If we are talking about the scope solution, you can see on this slide. So we see that we have embedded system like microelectronics, the carrier boards. On carrier boards, we just can put a system on module, SOC or SOM. And now we go to quite interesting part here. It's our application part where we touch CI/CD and DevOps. So as I told, Toradex also build and produce operating system and have some extra services for Horizon, like cloud services. But we, in this presentation, we mostly will be interested in these two levels for software, because actually the source code is stored and we build it. So it's software part of company portfolio. So we will not talk a lot about like system on modules and microelectronic itself, but talk a little bit more about CI/CD, DevOps, and how we build software. So to go further, let me quickly pose you a quick quiz. Can you just open the questionnaire, which should appear on your screen, and answer what Git platform are you using in your current project or in your current company? you can choose from the variants you can see on the screen. Don't hesitate to provide your answer. Give us 1 more minute for those who want to answer, provide their answers.
Yeah, we have more than 10 answers. I propose to see the results and see what platforms are mostly used.
Okay, let's review the responses. Okay, quite interesting. We see that a lot of people relatively use GitHub software as a service, but we also have quite big amount with GitLab hosted on premises. Also, we have Bitbucket. Yeah, so we have a variety of answers, not one big leader. But of course, yeah, all of us know that two main competitor here in this field, it's GitLab and GitHub. But let us continue. So let us go to the current Git landscape on Toradex project. So as I told before, I touch the topic of complexity, and in this diagram we definitely see how complex can be even Git landscape, because in Toradex we have my main GitLab instance, but also we have, as we have open source development, we need to somehow share the sources, because such sources they used in third-party CI/CD builds, and we also have a couple of separated Git servers just to store such sources for third-party builds, and as well as internal GitLab, some external Git services. We also have a couple of not accounts, but yeah, projects within accounts hosted on GitHub, just to provide opportunity for community to contribute to some layers or some software. So actually, even the Git landscape is quite complex, and that's initial step and our starting point. So our aim was to simplify such solution, to provide, I don't know, like to simplify all the stuff, and in ideal world switch to one solution instead of all of the small pieces, just to maybe switch to some kind of separated solution instead of having a lot of different platforms and accounts. Let us go next. If we are talking about GitLab instance key metrics, just to understand how big or how small it is. So we have around 2,000 of project, around 150 users, and amount of overall merge requests, it's around 80K of such merge requests. Then let's talk a little bit about architecture in general. So I take GitLab reference architecture as a starting point. And as you see in this slide, in simplest way, so GitLab proposes a couple of different reference architecture, and it can vary how many users you have or how many request rate or pull request rate you made, but it's hard to calculate such metrics, so we will rely on quite simple metrics, number of users. So I highly recommend you to discover this link with reference architecture and give some overview how complex it can be. But in simplest case, we can see that we have a couple of items here. It's typical microservice architecture with different components like Prometheus, database, PostgreSQL, cache, Redis, queue manager, Sidekick, or maybe you more know about RabbitMQ. It's the same type of software, and the storage. So it's a application consisting of a lot of microservices. and we will skip the next architecture on complexity and immediately switch to one level up to the architecture with up to which can handle up to 3K users. As you can see from this slide, the complexity is much more than we have on first slide. So almost each component which we considered before, like database or cache or queue processor, is horizontally scaling up. For example, Redis, we have a cluster, Gitali, which is a wrapper around the Git, so it's middleware which communicate with Git itself. It's also scaling up. And database, we have much more complicated. So we have a cluster of database and this PG bouncer, which serve your query in the right manner. Also, we have internal load balancer. So your architecture can be more complex quite intensively. We have more architectures, for example, up to 5K or 10K users, but we will not touch them. If you're interested, I recommend you to visit this link and see how huge and how complicated such GitLab platform can be in terms of architecture to serve high rate queries or just serve big amount of users. Let's switch to CI/CD, which essential part of Git platforms as of now. So in typical case, if we are talking about GitLab, it provides its own CI/CD. It's called GitLab CI. GitHub also provides the same functionality. It's called GitHub Actions. It's more or less the same declarative CI. So you write some kind of instruction in YAML or in TOML file, and Git platform execute it for you. It's quite flexible. Nowadays, it become more and more popular, even comparing to the Jenkins, which still, I believe, the known leader in this area of continuous integration. But this such declarative CI as a part of Git platform, they become more and more popular. We definitely can see it. So in Toradex, we use both. We use Jenkins and we use GitLab CI/CD as a process of continuous deployment, but for different project, different tool set. It's important to say that our CI is purely internal, so we keep our GitLab and our CI in-house, but also we need to communicate with other world, for example, fetch some sources. For example, Jenkins pipeline need to communicate with third-party sources. As I mentioned, like open source, it means you share the source with others, but you also reuse or grab sources from others. So it's constant way you exchange sources. You propose your sources and you grab someone's sources. And if we are talking about not complexity, but amount of our pipelines, I took real example from our instance. So we have number of pipelines just in GitLab CI/CD constantly growing. Now we have overall up to 100K pipelines. It's quite a big amount, and it's also causing some load in terms of execution. So let us consider like typical build task which we execute on our Git platform. So as I mentioned, it's embedded project and build tasks are quite specific. So in general case, maybe you don't have such task, but it's important to mention this specific, because this specific will play a key role in future, like in making effect on your decision. So we do intensive code linting and code quality checking. It's quite intensive CPU requirements. So we also build code for different CPU architecture. It's mostly ARM because it's embedded, and embedded it means mostly ARM, but yeah, nevertheless, we use x86. We also use some emulators like QEMU, and it's also built for such target, but mostly it's ARM. But this specific, it's also have put some limitation on our CI/CD. So, for example, to build for ARM, we use emulators because general purpose servers it's still on x86 architecture. So currently, it's a big move to have, for example, CI/CD runners based on ARM architecture. If I'm not mistaken, AWS is already providing some instruments for that, and even in-house, it's nice to have such CI/CD executors. But yeah, it's not a common things right now, but I believe it will be a future for differentiate CI/CD runners, not just to have it as a general servers. And also we intensively build Docker and Docker builds because, as I mentioned before, we have Horizon OS, which have Docker as a main runtime, and it means if you build application, and we also build some reference application for this Horizon OS, it distribute in the Docker. So if you build something in Docker, then you use Docker in Docker image. It's also bring some specific if you are talking about CI/CD, this Docker in Docker builds. So we did quite interesting experiment just when we consider, for example, to move our internal GitLab to the cloud, and CI/CD was highly a topic. So we did a comparison. So we took our bare metal servers, which you use as CI/CD executors, and we took 3 type of executors from GitLab. So GitLab in the cloud provide a couple of type of instances. It's really similar to the virtual machine in AWS type of instance, like small, big, and instance which support Docker and Docker. In this table, you can see that it have a slightly different number of CPUs. So all of them, it's a virtual CPU. So if you are talking about GitLab, they use this approach with Docker machine. So they spin up some kind of virtual machine in Google Cloud, if I'm not mistaken, provision the CI/CD executor, and that's all. You can execute your CI/CD on this machine. But this machine, nevertheless, it's still have the virtual machine and have virtual infrastructure. Also, we put our typical build task. We have structured them and put what is CPU requirements for each task. I slightly touched this topic before, so it's mostly linting in Python, linting in C++. It's built Docker and Docker, and I took as a typical task for comparison building the Linux kernel bootloader. So it's also essential part of the Linux kernel. It's a building of bootloader, and we also build it as a software. Also, it's important to have quantitative code characteristics, especially for the big repo. If you manage a quite big project with tons of lines of code, for example, Linux kernel, it's also important to know how quantitative code characteristic is changed from commit to commit. It's quite important for the for the project with high complexity. And let us go to the comparison. So in this graph, we purely compare productivity of our bare metal CI/CD runners with runners provided in the cloud. Because if you want to migrate your sources from in-house to the cloud, it's a native way also to migrate your CI/CD runner. Because if you are talking about big repository, it means the transfer always the sources are transferring from source code storage to CI/CD runner to execute CI/CD. So if you host in cloud, so it was initial proposition also to host your CI/CD in the cloud. But if we take a look, let me annotate. How we interpret these results. So on this axis, it's a time of execution. So less time of execution is better. Why? Because you don't wait too long. And if we talking about the typical task, for example, like that. So we see that cloud runners, they are not such productive. So it's a local runner, and this is a small instance of GitLab Cloud, and it's a big instance of GitLab Cloud. So we took linting, we took quantitative code analysis. So it's an all task which require heavy load on the CPU. And here we purely see that virtual CPU or virtual cores, it's not the same as a bare metal, unfortunately. So it's a limitation of this virtualization. So virtualization generally, yeah, you can reuse some resources of the bare metal server and give other resources to the other. So that's the limitation of virtualization technology itself. Unfortunately, now it become a industry standard, but for some tasks, and I prove with this graph, especially for compiling and any operation which require high CPU, this virtual CPU and virtual cores, they are not so productive. And unfortunately, nowadays GitLab platforms, they are not they cannot provide you with really bare metal machine. For example, in AWS, you can provision bare metal in cloud, but if you are talking about CI/CD executor for the modern Git platform, they propose just virtual cores, and yeah, you definitely see the results it's really different in 3 or even in 6 time of execution. Also, as I mentioned before, we use build. Let's switch to the more typical task. So in previous slide, we covered just heavy and quite specific tasks like linting and quantitative analysis on the code. On this slide, let's consider the typical task. It's really typical build task. So blue is building Docker in Docker images, and orange is building a Linux U-boot. So it's quite typical software build task with a make. And also we see here that that local runner is better compared to GitLab.com runner. So GitLab large runner, it's more or less equal here to the bare metal, but small, it's also not so powerful. And a typical build task, it take longer. And if you're talking about build task, in this case, you build each time when you submit a commit. So it might be different strategies. You might, for example, trigger it each night just to ensure you're not breaking something with previous commit, or developer are not breaking something developing on the previous day. But more acceptable is triggering CI each time when someone is doing the commit. Why? Because you immediately know that your code is still building, and it's more modern approach, especially it require more intensive CI and more requirements to the CI, but that's how recommended to do. So if you limited in resources, okay, you can just have some kind of scheduled pipeline, but we do build on each commit just to make sure you're not breaking something. Yeah, so that was comparison of CI/CD in the cloud, if we are talking about possible migration, if you decide to migrate your Git platform and you thinking, okay, what will be with my CI/CD? Should it take longer? Should I be able to act in same speed as I expect or not? But also within technical part, it's also cost of ownership part. If we are talking about comparison between on-premises and cloud, it's definitely some pros and cons as in each situation. So, for example, let's take cloud as a target for our Git platform. So it really looks good comparing to on-premise complexity. Remember such slides which I showed to you with 3K user architecture, 1K user architecture, and not to frighten you, I not show like, for example, 10K user architecture. So in cloud, you don't have all this complexity. You use it as a service, and you don't know or even don't want to know what this complexity is hidden between such cloud realization. Also, it's the same license cost per user as you use, for example, on-prem compared to what you use in the cloud. So now I'm talking just on the GitLab, but not sure if it's going the same for the GitHub. Also, no infrastructure cost, because running the server, it also means money, electricity, maintains, upgrade, some kind of recovery. So it's a pros of having your Git platform in the cloud. But also we have some cons. And cons, it's a cost of migration, because if you have complex Git platform, including some extra services like issues, Git pages, wiki. So we are not talking about just source code management, but we're talking mostly about all platform itself. And platform means some extra services. And extra services, it means complexity in migration. So GitLab, they have professional services team which can help you with such migration or even do this migration for you. Of course, it also costs some money. And if you have a complex Git platform with a lot of services, you need to be like really an expert to migrate it really flawlessly from in-house to the cloud. And quite interesting topic, it's also like cloud not for free. So for GitLab, they limiting cost of storage per project. So we, for example, have a couple of projects that definitely hit the threshold. If I'm not mistaken, currently it's 10 gigabytes per project for free. And all further storage, they have a model for pricing, because they also reutilize resources in the cloud for that. And also the cost of CI, the cost of CI is existing, and in GitLab is calculated quite interesting. It's calculated in CI/CD minutes. Let us get back to the graph. Yeah, so you see we have gitlab.com small instance and gitlab.com large instance. I say instance just for to ease the understanding, like in AWS type of instance. And in AWS type of instance, each type of instance, it means different money for 1 hour of run. The same concept lays here in GitLab. So they calculate you by CI/CD minutes, but this CI/CD minutes can be multiplied if you, for example, use a large instance and not small instance. For example, 3 minutes of execution on small instance is equal to 1 minute of execution on the large instance, just because it have more resources and your CI/CD minutes, you consume it faster. So cost of CI, it's also hard to estimate, because, for example, in bare metal, you don't count how many CI/CD minutes you execute. You just execute. You have your time as some kind of metrics, but it's quite hard to re-estimate your bare metal CI/CD execution into cloud CI execution as a service model, and also count the cost of ownership. So it's probably the two main parts, like pros and cons for the cloud hosting of the Git platform and in-house hosting of the Git platform. And let us do the summary on what I already told to you. So dedicated CI/CD runners is better if you have specific task which is quite sensitive to the CPU performance. As I told before, it's make pure compile C++ code compiling, especially linting of the code, do security check. All these tasks, they are quite heavy in terms of CPU. And when you switch to the cloud runners, you lost in CPU productivity, because such CPU, they are virtual CPU, and you share it with some other job. It gives you good flexibility. You have always available runners. You're not waiting in the queue, but you really lost in productivity. So if you want to boost your productivity, I don't know, maybe Git platform, they will provide some kind of solution. I see it as a good perspective because, for example, GitLab, they now propose not just to host your Git instance in SaaS together with all other, but they propose some kind of bare metal hosting. Maybe in future they will propose like bare metal CI/CD execution. So in this case, it's a good chance to have a mesh architecture. So mesh architecture, it's a flexible architecture. So you leave something in-house and you just move part of your CI, which is not have such high requirements for CPU, to the cloud. So in this case, we have some technical constraints, for example, like transferring the source code to the part of CI/CD executor which remain in-house. So you give better productivity of CI/CD, but you have higher network exchange. So it will be a good technique to use such pre-caching, or you can, for example, set how many latest commit you want to fetch to modify the fetch level of the source code. So somehow reduce the amount of source code you transfer to this in-house CI/CD executor with different technique. We also use this technique. And if we are talking about cost of ownership, so cost of ownership in cloud is better, but it's important from what point you are started. So if you started like in-house and want to migrate to the cloud, you need to consider the cost of such migration. So if, for example, you would ask me where to host your Git platform, and for example, you starting really from the scratch, yeah, then I would recommend to go to the cloud. If you just have a history or you have years of your Git hosting in-house, then it should be solution in each specific case. So you need to consider a lot of stuff and make the decision. But nevertheless, the mesh architecture, it's a good hint for you to use in your Git platform. That's actually all that I want to share with you today. We have a section allocated to the question and maybe discussions. So I open to your question. If any, I would like to answer.
Maybe if I can ask, which types of jobs would you recommend to place on the cloud runners? So which types of like regular jobs are not very CPU consumptive, and what is better to be placed there?
Yes, thanks, Konstantin. Good answer. For example, if you do build of the UI, some kind of front-end development, it's a good task to be distributed there. Also, if we are talking about the pipelines, you can have one heavy pipeline or, for example, a lot of lightweight pipelines. It's also up to developers how this CI/CD process is designed. And for example, in GitLab, you can split execution of each job in the pipeline. For example, you have pipeline at 10 jobs. 2 of them are high CPU, have requirements on CPU is high, and less, and all other, they are just, I don't know, like validating something or build UI, and then you can throw it to the cloud runner. So you can granulate it even on the job level. So we are not talking about the pipeline. So granularity in this case will be the job. But answer to your question, I would recommend to some jobs which are not which related to the front end or just validating something, but not validating the code.
Okay, yeah, thank you. And then using mesh architecture to divide runners would be probably the best solution for that.
Yes. So it's I don't want to say like know-how, but we really spend some time on such comparison in order to understand how our CI will behave, because we have, as I told, we have around 100K pipeline per month. So if it would be the wrong decision, we will greatly slow down overall our execution. And execution, it's also time of waiting, time of developers. It's important part. Before you migrate, we would like to understand what will be the productivity. And for our specific case, it would better to implement this mesh architecture, just not to highly lose in productivity.
Yep. Thank you for the answer.
Okay, any other question? Yeah, you can say by voice if you want, it's better. Okay, I see one question in the chat.
Yeah, is it audible?
Can you say once more?
Is it audible?
Yes, I can hear.
Yeah, okay. So how the existing templates will be used for your specific pipelines, like my existing templates, like I'm using Ansible templates and associated AML scripts. So how this AML scripts can be, because still we use this AML scripts to do the deployments via Ansible templates, so Ansible platform. So how it's efficient if you use our existing AML scripts can be utilized in the same way that in your CI pipeline to do the deployments or for use for executions.
As I got you, so you use Ansible. So your Ansible is doing your CI/CD deployment.
Yeah, we use AML scripts for the Ansible deployments. Yeah.
Okay, so in this case, your CI/CD runner, it's an Ansible runner. So, for example, Git platforms, GitHub or GitLab, they provide you with their own virtual machine, just like a Docker container. So potentially you can download Docker image of Ansible, then grab your YAML playbook from the Git repo and try to execute it. So it will be some kind of wrapping around your Ansible, because Ansible just supposed to run straightforward, but you can wrap it around CI/CD runner, and maybe in this case it will be a question, okay, how to provide passwords, how to provide secrets to this CI/CD node. So it's a couple of challenges here, but technically it's possible. So in your case, you just need to execute your CI/CD, which download Ansible, configure Ansible for you, download YAML file, and play it.
Okay. We maintain because the environment is hosted on like CyberArk. So so to exchanging the key and the certificates from the CyberArk to the runner platform where the execution's happening, deployment's happening. So yeah, so where we face the challenges at the moment. So that's why how are you encountered this? That's why I just asked.
Yeah, managing the secrets, it's also might be a challenge. For example, in our case, we have some jobs from the pipeline. They some jobs, they are producing artifacts, and such artifacts used by next job. It's really iteration. So for example, you build something, you produce artifact, and your next job is take this artifact and deploy it to the target. For example, in GitHub, you need to sign your artifacts because it's also a security breach. So you might build some artifact, mail form it, and try to deployment. So because of that, you need to sign your artifacts, and that's also a limitation. So you need, for example, GitHub Enterprise account for such actions. So in GitHub, you are a little bit limited in terms of such execution when you produce something as an artifact and you want to deploy it. So all the secret management, it's also a technical challenge in Git platform because you execute in the cloud, and if your intention is not so good, then yeah, you need to be limited. So for example, in Cloud Executor, I can say that you're quite limited in what you can, what resources you can try to use. Even this Docker in Docker builds, it's a separate executor in GitLab, just really because of you need Docker in privilege mode to execute some stuff. Okay, we have another. So, am I answered the question fully?
Yeah, I guess almost. Yeah, we can extend this conversations after this post call also via mail communication, and we can discuss a lot, I guess.
Okay.
Yes. Thanks for now.
So we have one question in the chat. What is your personal preference for hosting Git? It's an interesting question. So as I told, now Git platforms, they are much complicated than just simple Git. So from one point, it's a great advantage because you have all in once, you simplify your process, you speed up your process, you manage your process from one point of view. And from another point, this complication really gives you or leaves you without any possibility, for example, to switch to the platforms, because we also consider, for example, Bitbucket as an alternative, but just because Bitbucket do not have a lot of feature which we require, it's just more simplified Git platform with merge request, commits, and such functionality. We get rid from further consideration. We consider it on the early stages. And the answer where personal preference on hosting Git, first, you need to answer what functionality you expect from your Git platform. It's first. If you require like simple Git functionality or very simple Git platform, I recommend you to just take a look at simple platforms, because they are cheaper, but on cost of ownership, you just lose some functionality. But you need to answer, do I need such functionality or not? Because if you will pay for functionality you don't need, it's probably not good way to act. But also it's important to understand where you will stand in years, because if you are talking about Git, it's really a system which live for years and they become essential for the companies, especially if you produce or distribute or sell software. So in this case, I would take a look at something based on the cloud as SaaS, just because it have more perspective. Any other question, just feel free to speak or post in the chat. Okay, I think we finished here. So
Yeah. Yeah, I'm here. Thank you, Yuri, for this very fast, organized presentation with useful information. And thank you all for joining us today, for participating, for asking questions, and also for those who will be watching the recording as well. Just let's not forget to thank our speaker by leaving your feedback. Yuri, could you go to the slide with the feedback? And also you will receive this feedback form in a follow-up email together with the recording. Really hope to see you again on our future events. Please just stay tuned and have a great rest of the day. Bye.